Hi people, I have here a little box sitting on a table. So when I hit the box dead center, it moves forward without spinning. If I hit it slightly to the right, it moves forward and spin anti-clockwise at the same time. If I hit it slightly on the left, it moves forward and spins clockwise at the same time. So what does this motion tell us? So firstly, a force can have a translational effect and a rotational effect at the same time. And because of this, it might be a good idea to split the motion into two components. The first component is a translational motion of the CG of the object. The second component will be a rotational motion about the object's own CG. The net force acting on the object will determine how the CG of the object accelerates. And the net torque acting on the object will determine how the object rotates about its own CG. Take for example the motion of a hammer being thrown through the air. So this looks like a very complicated motion, especially if you track the movement of the end of the hammer. It's quite a complicated motion. But if you track the motion of the CG of the hammer, it's just a parabolic path. And it makes sense because the net force acting on the hammer is just the downward weight. So if you track the motion of the CG of the hammer, it's just a projectile motion. But on top of this, there's a rotational motion, in fact a constant rotational motion about the hammer CG. If you combine both the translation of the CG and the rotation about the CG, then we would have described the complete motion that's shown here. So this is quite a powerful technique, so let's have some practice here. So I have these four scenarios here. Let's say this circular object has a radius of 2 meters. That means the diameter is 4 meters, yeah? So given these scenarios here, can you figure out what is the net force and net torque and therefore predict what is the subsequent motion of this circular object? Alright, I assume you have given your own thoughts. I'm going to review the answers now. So for this one, the net force is of course 0 and the net torque is also 0, right? The two forces, one left, one right, and therefore they cancel each other out. As for the moments, well, both of these forces, their lines of action pass right through the CG of the object. So without any perpendicular distance, without any pivot distance, they both exert 0 moment. So this object is going to stay put, right? It's neither going to rotate nor translate. Now the next one here, we have a net force of 8 newtons because both of them are rightward, but the net moment is still 0. So this is equivalent to an object being subjected to just a force of 8 newtons acting at the center of the object. It's going to accelerate rightward, but it's not going to rotate. Okay, what about this one here? There's only one single force, and so we have a net force of 4 newtons, but the net torque of 8 newton meters, right? 4 newtons times the perpendicular distance of 2 meters to the center, or rather the CG of the object. So this object is going to accelerate leftward and also rotate anti-clockwise. Actually, this is equivalent to the object being subjected to a 4 Newton force acting at the center of the ball, and at the same time having this couple here that's producing the 8 Newton meters net torque. Okay, the last one here has a net force of 0 newtons but net torque of 8 newtons meters. This one exerts 0 torque because there's no pivot distance. This one exerts an anti-clockwise torque of 8 Newton meters. So what is going to happen to this object is it's going to stay put but rotate on the spot. Yeah, it's going to rotate about its CG. This equivalents to the object receiving just a couple produced by these 2 Newton forces here. So it will just spin about its own CG, but it's not going anywhere. Alright, that's all. Ta-ta!